Unit 12 is called Absolute Value and Quadratic Inequalities. We're going to start with lesson 12.1. It's absolute value equations. This will be a review of things that you really learned in Algebra 1. We talked about again in Algebra 2, but since it's been 2 years, let's go ahead and review it. It says to solve each absolute value equation for all values of x. This is something I wanted to show you to help you figure out what's happening here. This says that the absolute value of something needs to equal 5. Well, absolute value is just the value or the distance a number is from 0. And so if I ask you what number is 5 spaces from 0, you would say 5. But you should also say -5. And it would look like this, saying, okay, if x is -5, I plug it in, absolute value of that equals 5. And if I plug in 5, that also has an absolute value of 5. And so what happens is you get two answers. Not always a negative and a positive, but saying what gets plugged in here needs to come out to be 5 and then -5. So number 2, I can't just simply say like 1 and -1. I'm saying that whatever's inside of this absolute value needs to come out to be 5 or -5. Because I know that when I take the absolute value of this side, I can't have a -5 out of here that will turn into 5. And so what I want you to do is take the part that's in the absolute value out, never change it, set it equal to 5, saying, okay, what does x need to be to make this part come out to equal 5? And then what does that part, what does x need to be to make that part -5? So you're just adding 1. So x could be 6. 6 minus 1 makes 5. Absolute value of 5 is 5. Add 1 to -5. That does not get -6. That actually gets -4. -4 minus 1 is -5. The absolute value of that is what makes 5. So we get two answers. We're supposed to put curly brackets around it, but it doesn't really matter. Okay, so then level 1s are going to look something like this. You need to isolate, oh my goodness, I just spelled that wrong. Isolate the absolute value part first. Okay, so that's always step number 1, is get it by itself, because we need to know what does this part need to equal, and I don't know yet. So think about this being a negative, let me just put x plus 8 equals 4. If I asked you how to solve this for x, you would say, okay, well, I'm subtracting 8, and then I'm going to divide by -1. That's what we're trying to do here. This I just replaced with an x, but there's multiplication of a -1 times this absolute value plus 8 equaling 4. So to get this by itself, I would first subtract the 8, like we did here. Bring everything down. 4 minus 8 is -4. Then I would have to get rid of this -1 that's being multiplied times the absolute value, so I would divide by -1. So my absolute value needs to equal 4. So I'm saying that no matter what is inside of here, I know that when I plug a number in and add it to 4, I need to get this to come out to be 4 or -4. So I make my two equations and figure out what two numbers make that true. One number would be 0, because 0 plus 4 is 4, absolute value of 4 is 4. The other number would be -8. -8 plus 4 is -4, absolute value of that's 4. All right, and then number 4. It's very, very tempting to do 5 minus 2 first, but this is 5 minus 2 times something equals -9. So we can't subtract these since they're not like terms. We would have to get rid of the 5 first by subtracting, then divide by -2. That's what we're doing here. Subtract 5 first. -14. Divide by -2. So I'm saying that whatever's inside here, when I plug in a number for x, this should come out to be 7 or -7. So that I would subtract 2, that's 5 divided by 3. And it's okay to get fractions. So 5/3 is one of them. Subtract 2, that'd be -9 divided by 3. X is -3. Okay, level 2s, make sure you check for extraneous solutions. This happens because there's an X on each side, and extraneous means you get them as answers, but you go to plug them in to check and they don't work, so you don't count them as actual answers. The good thing about this one is this absolute value is already isolated, so I'm just going to say that 3x minus 7 needs to equal 4x, and 3x minus 7 needs to equal -4x. Okay, so I've got an x term on both sides. I'm going to subtract 3x. So I get -7 equals x. So there's one of them. Let's check real quick. If I plug that in, that would be 3 times -7 minus 7. The absolute value of that needs to equal 4 times -7. Which I know this makes -28. Already my problem is, how am I going to get the absolute value of something to equal a negative number? That can't happen, but I'll show you. 3 times -7 is -21, minus 7 more is -28. But the bars tell us to take the absolute value of that, which makes 28, not a negative. So that one is actually out. Let's try the other one. I'm going to subtract 3x. I get -7x divided by -7. So x is 1. Let's check. So this would be 3 times 1 minus 7 needs to equal 4 times 1. 3 minus 7 is -4. Absolute value, that's 4. And 4 times 1 is also 4. So that checks out. That works. And then number 6, absolute value needs to get by itself. So I'm going to subtract 2. So my absolute value needs to equal 2x minus 2. Okay, to make two equations, I'm going to leave the 4x plus 8 alone, saying that needs to come out to be the 2x minus 2, or a negative of the 2x minus 2. So it's like distributing a negative to both parts. Both parts are going to change signs. So now that's -2x plus 2. Like that. Okay, to solve, I'm going to subtract 2x on each side. Subtract 8. Divide by 2. I'll check here in a minute. Add 2x to each side. I'm going to subtract 8. 2 minus 8 would be -6. And so divide by 6 would be -1. Let's check. Okay, I'm going to do some mental math here. I can check here or here. It doesn't matter. 4 times -5 is -20. -20 plus 8 is -12, but it's in absolute value, so that'll make it 12. And then this side is 2 times -5 is -10, minus 2 is -12. That's not true, so that one's out. -1 times 4 is -4, plus 8 is 4. Absolute value of 4 is 4. And then 2 times -1 is -2. Minus 2 is -4. That's out too. So this one has actually no solution. On Delta Math, you'll just leave an empty set like that.